Total Grow has launched a revolutionary grow light designed to use as little energy as possible to generate light in the wavelengths plants need most for quick and healthy growth, using solid-state volumetric lighting, a next-generation light-emitting diode technology. To understand the value of this new technology, we must first take a look at the science. How plants really grow is a super complex process. But we took the challenge of learning more about the total story of how wavelengths benefit plant growth very seriously. After 2 years of research and consultation with growers and with universities and reading independent research studies, we've identified what we believe is the light spectrum that plants need most for speedy and healthy growth. For more than 40 years, scientists have known that plants absorb and use different wavelengths of light differently. For example, most plants appear green because green light is less absorbable by plants and is more easily reflected or transmitted. While photosynthesis is an incredibly complex thing, a closer look at the photoreceptors in plants reveals a built-in predisposition for certain types of light. Let's take a look at the 4 general regions of light that affect plants. The blue region. Research shows that the blue region is critical to the health and appearance of plants. Blue light drives dense growth, supports root development, and stimulates nutrient production and gas exchange. Blue light also prevents elongation, which is really important if you don't want your plants to look spindly or fall over. The red region. Research has confirmed that the red light is the most efficient at driving plant growth. The red region is where most of the plant's respiration takes place, which drives photosynthesis and speedy growth. Red light is also critical for flowering and day-length control. The far red region. The most compelling research about far red light suggests that its presence enhances the efficiency of other wavelengths in the blue and red regions. Or, said another way, it can act as a mini plant turbocharger. Several research institutions have conducted research on balancing red to far red ratios of light for optimal daylight extension, which is very important if you want fresh flowers on her birthday instead of a few weeks before or a few weeks after. The green region. As we have discussed, green light is much less absorbable to plants. Their green appearance is caused by reflecting or transmitting green light. While this trait makes green light the least effective in generating growth per photon, it also makes green photons the most effective for canopy penetration to stimulate subcanopy growth. Research has shown that small amounts of green light can be beneficial to the growth of plants, while large amounts of green light can actually inhibit growth. So it's important to manage the amount of green light generated for optimal growth. The Total Grow light spectrum was designed to give plants a broad distribution of wavelengths of light in the regions they need most for quick and healthy growth. We have focused the majority of our light in the red regions for quick plant growth and daylight control, and in the blue region for great-looking, healthy plants. The light that other technologies generate is based on physics, not biology. When you look at spectral graphs, it's clear that they don't always produce light in all the regions that plants need most. A closer look at high-pressure sodium reveals that most of the light is produced in the green region. While this is pretty effective for how humans see light, it is the least effective region for plants. High-pressure sodium produces very little light in the blue, red, and far red regions that benefit plants the most. Metal halide light generates more light in the blue region, but very little in the red and far red. Fluorescent light is typically distributed more broadly across the light spectrum, but has other technological inefficiencies that make it a less practical commercial grow light. High-pressure sodium, metal halide, and fluorescent lights are all technologies that rely on toxic heavy metal vapors to produce light, which creates a major environmental concern if these lights were to break near a food source. LEDs are a very energy-efficient and environmentally friendly way to produce light, and attempts have been made to use LED lighting for commercial growing. LED lighting technologies attempt to tailor light spectrums, but the physics of how LEDs emit light make their spectral output very narrow. Plants, which are amazingly complex, typically require a much broader spectrum of light than LEDs can emit. Another challenge for grow light technologies is uniformity of light. When grow lights produce hot and cold spots, plants have difficulty growing uniformly. Many growers get around this issue by moving their basil plants around, watering one area of their tomato plants more or less than others, or fertilizing their lettuce more or less in certain places. Farmers have developed all sorts of tricks to try to compensate for the shortcomings of other lighting technologies. But Total Grow simply creates uniform light. And farmers are telling us that their plants and their backs are loving us.
Hi, my name's Lynn Kemme. I'm the owner-operator of Great Lakes Hops. We're located in Zeeland, Michigan, and our main function in here is that we're a propagator for new hop varieties for the craft brew industry. We found that installing the Total Grow light system has reduced our rooting times on the benches, improved our plant quality, and is generally just speeded up our whole operation, which allows us to do more cycle turns and therefore expand our business without having to actually put up any more greenhouse growing space. We tested the Total Grow light system first, and we found out that our plant response was much better. We had better color, faster rooting, and we decided to pursue it from there. We found that the payback in energy savings was something that we're looking forward to because we anticipate saving thousands per year on our electric bill compared to the sodium halide systems that we replaced.
With the Total Grow lights, we are growing about 40 varieties of lettuce, along with bok choy, watercress, arugula, and then multiple different types of herbs. The Total Grow lights have really increased the weights of the lettuce. When we were growing without the lights, we were getting much smaller heads, especially in the winter. And with the Total Grow lights, the volume, the weights have really increased. The other lights that can be used for this type of process are metal halide or high pressure sodium. Both use a lot more energy and produce heat with their lights. The Total Grow lights use far less energy and produce a light that is more beneficial to growing, since it's just the color spectrum that the plants use. We are also starting our seedlings with some Total Grow lights, and that has been really spectacular in the growth that we're getting with those compared to the T5 fluorescent lights that we have been using. The plants are much heavier weights and much denser growth compared to the fluorescent lights, and it's just been very impressive for us, and we are just excited to change everything over to those.
The Total Grow TG15A includes 15 solid-state volumetric light packages generating 150 watts of uniform light with a spectrum optimized for plant growth. It contains no moving parts or toxic heavy metal vapors and is easy to install. UL certification for damp locations and a projected service life of 30,000 hours makes the TG15A an ideal solution for commercial growing.